and welcome to Maths Made Easy. Today I'll be explaining adding, subtracting, and multiplying matrices. And trust me, it's a lot easier than you think. These are the table of contents. First, I'll be explaining how to add matrices and the rules that come with it, how to subtract matrices and the rules that come with it, how to multiply matrices when it comes to scalar multiplication, and how to multiply the matrices that come most often, which are usually non-scalar. And one thing I will add, adding and subtracting matrices are very similar, alright? So, before we dive in, what are matrices? Matrices, if I could say it in simple words, are a rectangular array of numbers, symbols, expressions that represent a mathematical object. Other mathematical objects you may know are formulas, expressions, different shapes, etc. Matrices are organized in rows and columns. For example, in this matrix here, you have 3 rows, 1, 2, 3, and 2 columns, 1, 2. So these show the number of rows and these show the number of columns, which is why we can say that the dimension of this matrix is 3 by 2 or 3 times 2. But why can't we say it's 2 times 3? This is because the number of rows always come first when defining a matrix. So we can't say that this is a 2 by 3 matrix. Matrices are also used in real life to plot graphs, find statistics, but also help conduct scientific studies. But my favorite part is that you can even use matrices to write secret messages. Let's practice finding the number of rows and columns. So, take some time to try to figure out how many rows and columns, basically what the dimensions of these different matrices are. Alright? Okay, so here we have a 2 by 3 matrix. Here we have a 2 by 2 matrix. Here we have a 3 by 1 matrix. Here we have a 1 by 3 matrix. Here we have a 3 by 3 matrix. And here we have a 2 by 2 matrix. And the I here is actually an imaginary number, also known as the square root of -1, but we don't need to worry about this too much. And yes, there can be letters and symbols inside matrices, which we will see in the future. So, adding matrices. Matrices must have the same number of rows and columns to be added. And the addition is actually quite simple. Here we can see that we have a 2 by 2 matrix and a 2 by 2 matrix. Therefore, we know that we can add them. And from there on, you just add the values corresponding to each area. So here, you would add 1 plus 12. You would here add 5 plus -1. You would add 7 plus 0. And you would add 3 plus 9, which would give you 1 plus 12, 13. 5 plus -1, which is 4. 7 plus 0, which is 7. And 3 plus 9, which is 12. So you add based on which area corresponds to which. So here, 12 is in the same area as 1. 5 is in the same area as -1. 7 is in the same area as 0. And 3 is the same area as 9. So let's take another example. Here we have a 3 by 3 matrix plus a 3 by 3 matrix. So we know that the dimensions are the same, which is why we can add them. So here we would do 2 plus 5, 2 plus 7, which we can see here as well, 1 plus 1, here would be 1 plus 0, 5 plus 3, and so on. And this would be your final matrix. So, let's practice. Take some time to try to solve these problems below, and we'll see if we found the same answer. If you're able to figure these out, here, your first element would be 17 because you have 8 plus 9. The second element, which is your B value here, would be 5 plus 5, which is 10. Your third element, also known as C. So one thing I want to explain. Your first element is always A, which is here. Your second element is B, which is here. Your third element is C, which is here. And your fourth element is D, which is here. And this is only the case for this specific matrices, which has these specific dimensions. So those will change accordingly based on the number of dimensions. The number of rows and columns that you have. Alright? So, let's proceed. With this example here, your first element would be 4 because you have 1 plus 3. Your second element would be negative 3. Your third element would be 4 plus negative 2, which would give you 2. And your fourth element would be 2 plus 1, which is 3. So you would have 4, negative 3, not negative, just positive 2, and 3. And here, this is something I need to explain because this is one of, actually the main rule when it comes to adding matrices. You can't add matrices that have different dimensions. Here, we have a 3 by 2 matrix, and here we have a 2 by 3 matrix. These do not have the same dimensions, therefore they cannot be added. So, that was it when it comes to adding matrices. Now let's move on to subtracting matrices. Similar to adding matrices, matrices must have the same number of rows and columns to be subtracted. Or in simple words, they must have the same number of dimensions, or just the same dimensions. So, for example here, you almost do the exact same thing. You multiply with each corresponding area. So here, you do 5 minus 1, which is 4 for your first element. You would do 6 minus 2, which is 4 for your second element. You do 7 minus 3, which is equal to 4 for your third element. And you do 8 minus 4 for your fourth element. It's that easy. And here, there's another example. You would do 8 minus 9, which is negative 1. 5 minus 5, which is 0. 2 minus 1, which is 1, and 3 minus 2, which is just 1. We have another example here, but this time with variables, so you can actually see it. So here you have A1 minus B1, you have A2 minus B2, you have A3 minus B3, and A4 minus B4. And here, one last example, you have, and it's also very important to pay attention to the signs. Here, you would think that it's just 8 minus 12, which would give you negative 4. However, there is a negative number already as the element. So you would do 8 minus negative 12, which order of operations, this would become 8 plus 12, which gives you 20. So here, we would have 8 plus 12, which is 20. Here, we would have 15 minus 0, which is 15. 7 minus 2, which is 5. And negative 3 minus negative 11, which is negative 3 plus 11, which is 8. So you would get 20, 15, 5, and 8. Now, let's practice with these. So take a few minutes if you need to try to subtract these different matrices. So, I can take one of these for an example. We can take this one. Here, you would have 5 minus 2, which is 3. So that would be your first element. You would have 3 minus 1, which is 2. 7 minus 9, which is negative 2. 0 minus 7, which is negative 7. Negative 5 minus 4, which is negative 9. And 4 minus negative 2, which is 4 plus 2, which is 6. I don't have enough space to write this actual matrices down, but you get the idea. And one thing, what would this be? If you didn't figure it out, this actually isn't even possible, because here we have a 2 by 3 matrix and here we have a 2 by 2 matrix, and they don't have the same dimensions, therefore you can't subtract them, which I've explained here as well. So we're already done with adding and subtracting. So now we're going to move on to scalar multiplication, to multiplying matrices. First, let's start with scalar multiplication. Scalar multiplication is when you multiply an entire matrix by just one number, and it's really simple in these scenarios. So here you would just do normal multiplication, but you'd multiply 3 by every single element. So here you would do 3 times 2, 3 times 0, 3 times negative 1, 3 times 6, 3 times 5, and 3 times 6. And if you do the math here, you will get 3 times 2, which is 6, 3 times 0, which is 0, 3 times negative 1, which is negative 3, 3 times 6, which is 18, 3 times 5, which is 15, and 3 times 6, which is 18. And another example here, you would multiply all of these elements here by 2, so you would get 2 times 4, which is 8, 2 times 0, which is 0, 2 times 1, which is 2, and 2 times negative 9, which is negative 18. And another example here, if A is this matrix, 2A would just be all of these elements multiplied by 2, which is 2 times 3, which is equal to 6, 2 times 7, which is equal to 14, 2 times 9, which is equal to 18, and 2 times 10, which is equal to 20. Now, let's practice with these singular matrices. So, I can take any of them for an example. Let's go with the first one. So, we would multiply each element by 3. So here we would have 3 times 7, which is 21. After calculating 21, then we'd have 3 times 5, which is 15, 3 times negative 10, which is negative 30, 3 times 3, which is 9, 3 times 8, which is 24, and 3 times 0, which is just 0. You can take another example. We can go with this one. We'd multiply every single element inside the matrix by 2. So we'd have 2 times 2, which is 4, 2 times 3, which is 6, 2 times 1, which is 2, and 2 times 2, which is 4, 2 times 2, which is 4, and 2 times 5, which is 10. I can actually proceed with the next two as well. Here, we would have negative 3 times 5, which is negative 15, negative 3 times negative 5, which is positive 15, negative 3 times 0, which is 0, and negative 3 times 12, which is negative 36. And again here, you multiply all of the elements by 3. So you would have 3 times 1, which is 3, 3 times 2, which is 6, 3 times 3, which is 9, and 3 times 4, which is 12. Now, let's move on to multiplying matrices that aren't singular. Now, this is where it can get a little bit tricky, but with some practice, it can get very easy. First of all, we can only multiply two matrices when the number of columns of the previous matrix is the same as the number of rows in the next matrix. And heads up, you can have several matrices when multiplying, but what I mean by this is here, where it's shown clearly, here we have a 3 by 2 matrix, and here we have a 2 by 3 matrix. The number of columns in this matrix needs to be equal to the number of rows in the next matrix. So here we can see that they are equal, which is why we can multiply them. If this instead was a 3 by 3 matrix and this was a 2 by 3 matrix, you would have 3 and 2, and they're not the same, therefore we cannot multiply them. So, can we multiply this matrix here? Yes, we can, because this is a 1 by 3 matrix and this is a 3 by 1 matrix, and since the two numbers in the middle are 3, we can therefore multiply them. So, how would we work with this matrix? See here, we would multiply 2 by 1, which is 2, 4 times 4, which is 16, and 6 times 7, which is 42. We would add all of those and you would get 60. This visual is a bit difficult to understand, so I can actually explain it with one of the examples above here. So this is how it would look. If we take them as variables, how it would work, we would bring B11 on this side and we would bring B21 on this side. So I can repeat that again. If you think of these as A and B, you would bring A here like this, and you'd bring B21, seeing that as B, and you'd bring it here like that. So you have A here and B here. And now how would that work? If you're trying to find the first element, you would do B11 times A11 plus B21 times A12. For your next element, you would do, so for your next element here, you would do B11 times A21 plus B21 times A22. It can be a bit tricky, but with some practice, it'll make sense. And just to understand, here's the visual representation, which you can just look at to try to almost figure out the variables with every other area. So another example, if you're trying to find this, you would do B11 times A31 plus B21 times A32. But notice that we have a 2 by 2 matrix. So this is just the first part. You would have your second part as well. And how would you find this? You would do Now bring the B12 here and B22 here, like we did with these first two elements. And then you would do A11 times B12 plus A12 times B22. Then you would do A21 times B12 plus A22 times B22, and so on. And here there's another visual representation. This makes it very clear, in fact, because here you have numbers 1, 2, 3, 4. You have the matrix A and you have matrix B. How would you multiply? To get this area, you would do 1 times 6, which is equal to 6, plus 2 times 8, which is equal to 16. And 6 plus 16 would give you an answer of 22. And we can do this with the first example. So let's say we take this area, we would do 1 times 5, which is equal to 5, plus 2 times 7, which is 14. So we would have 5 plus 14, which gives us 19. And like I mentioned before, with some practice, it becomes really easy. In the beginning, it can be quite confusing, but the more you do them and the more you try to process and understand these different matrices and how to multiply them, the easier it gets. Thank you for listening, and hope you enjoyed this video, and we'll see each other next time.